highly missed question of the whole test. For all the 8th graders, I think only 15% got this right. That means a whole lot of people got it wrong, okay? And I think it was just simply a situation where reading the question and understanding what it's asking was troubling for some of y'all. Because it says, in the equation above, what is the coefficient of the oxygen molecule? Well, here's the equation. The oxygen molecule is right here, O2. And it says, what's the coefficient? Most people put 2, but 2 is not the right answer. Why is 2 not the right answer? Why?
Number 2 is the, so I know it's the, it's got
starts
the
with an S.
I know it is.
Okay.
Like the,
Okay, 2 is called the subscript. Okay? And so 2 is not the answer. It says, what's the coefficient, which is the number in front of the molecule?
There's none.
There isn't one. So what is my number?
0.
1.
1. If there's nothing there, it means there's one item. Okay? Because you remember when we would balance chemical equations, and if we didn't have one we were supposed to put there, we'd put a 1 in its spot? Y'all remember that? So one is our answer. Does everybody understand why?
I couldn't write.
What if it said, what's the coefficient of the molecule magnesium?
2.
Yeah, that one's got a 2 in front. If we took away that 2, it would also be an invisible 1. Okay, a 1 is like a placeholder. Okay, not 0, but 1. Okay. Okay, number 2. New substances formed during a chemical reaction are indicated where? What side of the arrow sign would the new stuff be on?
Right.
Right side. So letter F, does it say right or left side? Left, so that one's already out. Letter G, does it say right side?
Yes.
Okay, so that could be an answer. How about H, does it say left or right side? That's out. And J, does it say left or right? Okay, so let's figure out which side. We said it should be on the right side, and what do we call this stuff on the right side of the arrow? Products. So G says on the right side of the equation are called reactants. Now, J says on the right side of the equation are called products.
Yes.
Yes. Okay, just knowing where they're located is what this question was asking. Number 3. All chemical equations must be balanced. This means that the same number of atoms of each of the elements must be found in both reactants and products of the reaction. Which scientific law does this illustrate? Okay, so basically saying that on the left side of the arrow, if we have oxygen atoms and there's 12, we need to have 12 oxygen atoms on the right side as well, on the product side. What law states that? Law of conservation of mass. What does that law say?
That matter can't be destroyed or
Created or destroyed.
Okay, it can't be created or destroyed, it only changes form, okay? The law of conservation of energy basically says the same thing, but it's energy instead of matter, or mass. Basically it says the law of conservation of energy is energy cannot be created or destroyed, it just changes form. But that didn't relate to this particular 6 weeks. We hadn't talked about that one yet. We've never talked about the law of superposition. I'm not even sure what that one means. And the law of reflection we've never talked about either. That has to do with physics, okay? Okay, let's look at 4. Which of these equations shows rust, Fe2O3, forming when oxygen O2 reacts with iron Fe? All this is like a math story problem. Do you know what that looks like when it's written out correctly? Let's look at some key things. It says rust, Fe2O3. So if you don't know what rust is, it tells you what it is. It's Fe2O3. And it says it's formed. So if it's formed, would it be on the left or the right side of the arrow?
Right.
Right side. So we're looking for Fe2O3 on the right side. Does F show that? Answer F.
No.
Does G show that? Yes. Does H show that?
No.
Does J show that?
Yes.
Yes. So then it says when it reacts with oxygen, O2 with iron, Fe. So does G show a reaction with both oxygen and iron on the left side?
No.
No. Because it also shows oxygen as a product. That's not what it is. J. 3O2 plus 4 Fe yields to Fe2O3.
Yes.
Yes, that's it. So these were the reactants, and Fe2O3 was the product. Okay? Any questions there? Okay, let's look at 5. It was a balancing chemical equation problem. It says, in the reaction described by the equation above, what coefficient should be added to the box to represent the number of water molecules produced during the reaction? So if you notice, the box is in front of H2O. So we're looking for H atoms and O atoms to balance. So look on the left side of the arrow. How many oxygens do we see? 2. How many hydrogens do we see?
4.
4. So how can I make, on the right side, by putting a coefficient, how can I make that hydrogen become a 4?
2.
Okay, would that also make the oxygen a 2?
Yes.
Yes, so that's my answer. Okay, any issues with that?
No.
Okay. Okay, number 6. A student mixes 2 solutions, planning to produce carbon dioxide. Which of the following is the best evidence that a chemical reaction is producing carbon dioxide? What is carbon dioxide?
It's a deadly gas.
It's a gas. It's not deadly because we're actually breathing it in and out right now, even though our body's not absorbing it because we're breathing it out. But we also breathe it in. So it's not going to kill us. But what is it then in a reaction that shows us gas is being formed?
Bubbles.
Bubbles. So letter J. Okay, number 7. When determining an element's chemical properties, the most important subatomic part to look at is what?
Valence electrons.
Valence electrons. Good. They're the ones that are going to change in a reaction. They're going to cause atoms to share electrons or give or take away electrons. What do we call an atom that shares electrons with other atoms? They share them together.
An anion.
Good. Covalent bonding. What do we call it when an atom gives away or takes electrons? Ionic bond. Good. Okay. Be good at Jeopardy, Joseph. Okay, number 8. How many protons would an atom of magnesium have? We'd actually have to look at our periodic table. Okay? And so if I grab one real quick. Okay, here's what I see for magnesium in the box. I see a 12 at the top. I see Mg. And I see 24.305. Which of these numbers tells me the protons?
The top.
Okay, what do you think, Carlos?
The 12.
Okay, good. This one right here. That tells me protons as well as electrons. So that's what I'm looking for. Okay, remember this number is a total of protons plus neutrons. So normally we use that number to round and subtract the 12 to get the neutrons, right? Okay, any questions with that one? Okay. Number 9. Okay, 9 I'm a little concerned about, but it shouldn't have given us wrong answers, hopefully, in the process if we read it correctly. The reason why I'm kind of confused by the way it's written is it says a charged atom has been discovered with 16 protons, 17 neutrons, and 18 electrons. Well, it has the protons wrong in the picture. Okay, I didn't count the electrons necessarily, but that kind of leads to some issues with this a little bit. Knowing that it's charged means that it has gained or lost an electron, okay? Which really doesn't apply to the questions that it asked. The question says, what type of atom is this? Well, if it has, if you notice it has 16 protons, okay, which shows sulfur. Who got that right? Who put sulfur down, okay? But if we look at this one, it says 18 protons, or does it show 16 on y'all's? Am I reading this wrong? Does it look like 16? Okay, so this is just a fuzzy demonstration. So this is okay then. That says 16. So that's good. Because I thought it looked like 18 on the overhead. I was like, something's wrong. But if it matches up, then we're good. Okay, on the overhead it looked off. But we're okay then. So the answer is sulfur. Okay. Okay, number 10. What is this atomic mass? Okay. How do we find the atomic mass?
You do protons plus neutrons.
Good. We take these two numbers and we add them together because the mass is what's in the nucleus. So 16 plus 17. And what do we get?
33, right?
Yeah. 33? Yeah, 33. Okay? So that's our answer for that one. We just add what's in the nucleus. Okay, number 11. I think a handful of people missed this. How many people got this right in here? Number 11. Okay, so let's see what caused some problems with this. It says, what conclusion can you make about the elements shown above? Okay, so we got phosphorus, nitrogen, carbon, is that silicone? Yeah, silicone and aluminum. A says phosphorus has more valence electrons than nitrogen. So this has more valence electrons than this. Is that a true statement?
No.
Why not?
Because, wait. Because
How do we determine a group or How do we determine an atom's valence electrons? What group it's in. So that happens to be group 15. Group 15. So how many valence electrons do they have? 5. So does one have more than the other?
Yeah. No.
No, they're in the same group. So that doesn't work. Okay, let's erase this so we can kind of see what's going on with the rest of it. Okay, how about B? Carbon has fewer protons in its nucleus than nitrogen.
Yes.
That is true, because it has 6 and nitrogen has 7. Let's look at the other ones, though. Letter C. Phosphorus is more like silicon than like nitrogen. So this is more like this than this. Okay, which ones are alike? The ones that are in the same period or the ones in the same group? Same group. Same family, right? We call them families also, right? Because they have things in common. So these guys actually have more alike than these guys do. So that's wrong. Okay? D. Aluminum is smaller than carbon.
No.
His atomic number is 11. Carbon's is 6. We can also look at the mass, and they're much different. Carbon is actually less or smaller than aluminum, so that's wrong too. Okay? All right, everybody cool on that missed it?
Yes.
Okay. 12. Which of these groups or columns in the periodic table is made up primarily of elements that are gases at room temperature? Which group is all gas?
18.
Group 18. What do we call group 18?
The noble gases.
Noble gases. Remember, they also have a full valence ring, so they don't react with anything else. Okay? That's why we call them noble. Number 13. In a chemical equation, what do S, L, and G represent? So if I have H2O, and I see a little italic G on the side, what does that tell me about that water?
Yes.
It's a gas, right? It's evaporated. Okay? What if it's H2O, and it has a little L right here?
Liquid.
Liquid. What if it's H2O and has an S right
Solid.
there? Solid. So what is the right answer for this?
D, the physical states of matter, the reactants and products.
Yeah, D, the physical states of matter and the reactants and products. So basically, is it a solid, liquid, or gas? That's what that stands for. Number 14. How is the arrow read in a chemical equation?
Yields.
Yields. Remember, we don't use equals like we do in math. We could say produces, but really the better term is yields, and produces isn't there anyway. Okay? The formula for glucose is C6H12O6. How many elements does glucose contain?
3.
3. Carbon, hydrogen, oxygen. Now, some of y'all might have put 24 because you just added up what you saw in the subscripts, and that's not true because the question doesn't attack that. If that were the answer, then the question would say something like, how many atoms make up a molecule of glucose? And that would be total atoms, okay? Okay, number 16. In the chemical reaction, it is the action of the blank that is responsible for the changes taking place.
Electrons.
Electrons, good. There's actually 3 questions in this test pertaining to electrons because they are so important in regard to the behavior of atoms, okay? Okay, 17 was simply being able to read this chart. It says, what does H2O2 stand for?
Hydrogen peroxide.
Hydrogen peroxide, right here. Okay? And also, you should know that anyway, just because of the lab we did where we looked at water and hydrogen peroxide, right? And Jaime, almost tosses cookies in the trash can, right? Okay, let's look at 18. Which of the following is a chemical property of iron? What do y'all think there?
J, conducting electricity.
Actually, it is
No.
rusting.
No.
Can we turn rust back?
No.
Nope, once it's rusted, it doesn't go back to iron. That's the clue for chemical reaction.
Undo that. That's
Okay.
the wrong answer.
And if y'all got that wrong or y'all guessed and got it right, you may want to put next to the other options there that those are all physical properties. Okay, melting when heated, that's physical. Sticking to a magnet, that's physical. Conducting electricity, that's physical. Okay, those are all 3 physical properties. Okay. Number 19. Which of the following is a chemical property associated with wood? Which one would not turn back to wood?
Ability to burn.
Yeah, if you burn it, it's not going to be wood anymore. Okay. All the others are physical properties: snapping when bent, floating on water, having a rough surface. Okay. 20. Students collect rock samples on a field trip and test them for different properties. Which of the following is a chemical property of rocks?
Reacting when tested with a drop of acid.
Yeah, and see that word reacting is a big sign chemical reactions are going on. The other ones are still physical. Okay? Yeah, if it has white color, if it has a rough surface, if it's being easy to scratch on metal or whatever, then that's also going to be physical. Okay, 21. Which of the following demonstrates that a new substance can be formed from a chemical reaction?
Milk sour.
Yeah, milk souring, because I can't get back to regular milk once it's sour. Something new has happened, okay? All the other stuff, water evaporating, it's still water. Iron bending, it's still iron. Just because we put helium in a balloon doesn't change it. It just shows that helium floats because it carries the balloon upwards. So those are all physical properties, okay? Yeah, milk souring, it changes it totally. Nobody likes sour milk, hopefully. It's gross and makes you sick. 22. Which of the following is one way that compounds are formed?
Sharing electrons between atoms.
Yeah, sharing electrons. So a covalent bond, right?
Yes, sir.
Always electrons. The electrons are always the thing that goes on in chemistry with atoms. Okay, 23. I think a few people missed this one. You never saw a chart like this, at least in my class, until this test. But hopefully you can tell what was going on. You see all these arrows going back and forth, and you see the words melting, freezing, condensation, and evaporation, and you see phase 1, 2, and 3.
Water cycle.
It is the water cycle, yes. And so what is going on? Is it a chemical change, irreversible change, physical changes, or continuous changes?
Physical.
They're physical. Even though they are somewhat continuous, they keep going in cycles, they are all physical. We're talking about chemistry in this class, so physical changes, chemical changes, that's really the best answer in this test, okay? Okay, now we're down to a chemical equation and balancing. Okay, so let's balance this real quick. Na plus H2O yields NaOH plus H2. Okay, so let's count up our atoms. Okay, how many sodium atoms do you see on the left?
We see 1,
Okay, how many hydrogen atoms do we see?
2,
How many oxygens? 1, good. So on the right side, how many sodiums?
1,
Okay, how many hydrogens?
3,
3, good. How many oxygens?
1.
1. Okay, so looking from left to right, everything balances except for the hydrogens. Well, when I look on the left side, they go up by 2. The right side goes up by 3. At least there's 2 of them that we could change. So we want to try to get these to match up. Well, there's a few ways you could actually use the answer choices to narrow down your options. You could actually plug all the answers in and see if they balance, and then scrap that answer if they don't balance. That's time consuming, but it's an easy way to check it out. But let's use it for another purpose. I know that I want my hydrogens to balance. And the one I'm most concerned about is this one right here. Because right now I could have odd or even possibilities with hydrogen depending on what coefficient I'm messing with. Okay? And so when I look at that, I want to look at what options it gives me. It gives me either a 2 or a 1. Most of the choices are 2. So I'm going to bet the answer is probably 2 right here. Okay? So let's go ahead and try sodium. Sodium changes to what? 2. Hydrogen is now what? It's 2 here, but we also have 2 here. So 4. Oxygen is now 2. Good. So now can I get this hydrogen over here to go to a 4? What do I need to put there? 2. So now hydrogen's a 4. Oxygen just changed to what? 2. So now we're balanced. Well, we're not totally balanced. Nitrogen has to change too. What do we got to do there? Or sodium, I'm sorry, not nitrogen. Put a 2 right here. Now it's 2, 2, 2, 1. Okay, do we have that answer choice over here?
Yes, G.
Okay, G. Good. 2, 2, 2, 1 right there. Okay. Now, like I said earlier, if you had trouble doing this, you could just plug in all the answers from each answer choice and see if they balance and see which one checks out. Okay, any questions there? Okay, 25. Last one, and balancing equations again. So we have Na2SO4 plus Mg yields a Na plus MgSO4. Okay, so let's count them up. How many NAs are there?
There's 2.
How many S's?
1,
How many O's?
4,
4,
How many Mg?
1,
1,
Okay, on this side, how many Na?
1,
How many S's?
1,
Good. How many O's?
1, 4,
No, 4 there. How many Mg's?
1.
So when I look across, everything is balanced except for what?
And A.
Na, and that's all by itself. So all I need to balance it is to put what there?
2.
The 2. So that changes sodium. Everything else was good. So what should I put in the blanks?
1.
So 1 everywhere else. Okay, so what's my answer then?
1, 1, 2, 1.
Good. A. Any questions there?
No.
Okay, good.